So let's just talk about the B plus tree. So the B plus tree is similar to the B tree. So we have talked about this B tree earlier. You can check that video for better understanding. So this B plus tree is also one self-balancing tree data structure. That means here it maintains sorted data, and here also we can efficiently perform insertion, deletion, searching, and also we can perform the range queries. So like an example, here we have one B plus tree. It looks exactly like the B tree. So suppose we are talking about one B plus tree of order 5. That means here maximum child each node can have is 5. The minimum number of child that each node can have, which is 5 by 2, and ceiling of that number. So that means this will be 3. So that means each node can have maximum of 5 children and minimum of 3 children. Now here each node can have maximum key, which is order number -1. So that means each node can have maximum of 4 keys. Now here the minimum key will be minimum number of children, which is 3 minus 1, so it will be 2. So that means each node can have minimum of 2 keys. So all of these calculations are similar to the B tree. Now we have exception for the root node. Now in case of this root node, the maximum number of children will be 5, which is similar, but the minimum number of children is 2. Now also in case of the root node, the maximum number of key that it can have is 4, which is similar to the other nodes, but here the minimum number of key can be 1. So which is the exception in case of this root node. So here you can see this is our root node. So you can see it has one single key, which is the exception for the root node. These are all the internal nodes and these are all the leaf nodes. So you can see all of these leaf nodes are at the same level, which is the property of the B plus tree. Now also here in B plus tree, all of the data stays at this leaf level. So these are all the actual data and they are stored in the leaf node. Now this internal nodes only stores the key, and here we do not have any actual data. So these are keys and that will help us route our tree. So suppose you are looking for some value. So suppose you are searching for value 50. So these nodes will help us reach to that specific value. So here 50 is greater than 28, so we're gonna go right. It is less than 53, so we're gonna go left. And here you can see we have found the value. So the internal nodes are basically used as index. These are the keys that we use to reach to our specific value. These are not actual data. So you can see here we have 6, also here we have 6. Here is 20 and also here we have 20. So these are not data. These are basically keys to reach to the actual data. And not just this, in this leaf level we have link between these nodes. So here all of the leaf nodes are connected using the link. So that means here we can perform the range query. So because they are all connected, so we can start from one end and we can traverse all of them. So all of these data can be accessed in sorted order. So the question is why we should use the B plus tree. So first of all, here we have efficiency, and secondly here we have faster range query. So that means because all of the leaf nodes are connected using the link, so because of this we can perform the range query very fast. And thirdly, the B plus tree is scalable. So that means we can scale this and even we can work with very large data set. So let's now talk about some of the important application of the B plus tree. So first of all, it is used in case of the database indexing, like in the MySQL database or in Oracle database. And secondly, we can use that in file systems. Like an example, we have the file systems like NTFS. So hope you understand about the B plus tree. In the next video, we're going to talk about different operations on the B plus tree. Thank you.